All right, let's look at the homework 7.5, problem number 7. All right, so this is a rationalizing substitution example. All right, so let's do that. All right, so I'm going to set the let u be square root of 4x plus 49. All right, since I don't like square root, I'm going to go ahead and rewrite it as 4x plus 49 quantity, raise it to the 1/2 power. Right? So let's just go ahead and take the derivative of u. Right? So derivative of u with respect to x would be, right? So put so it's a power rule, so 1/2 in front, and keep the inside function as it is, so 4x plus 49, and subtract 1 from the power, so it's a negative 1/2. Then we need to multiply by derivative of inside, which is 4. Right? So we can cancel 2 on the bottom and 4 on top, so there's going to be 2 left over. Right? So this is going to be equal to, let's see, you're going to have 2 on top and over. Right? So it's a negative power and it's a square root, so it's a square root of 4x plus 49. Right? But the denominator is same as u, so I'm going to go ahead and write it as a 2 over u. Right? Then we want to find dx, so first we take the reciprocal of both sides, so you have dx over du, and this is going to be equal to u over 2. Right? Then multiply through by du. Right? dx is equal to u over 2 du. Alright, so let's rewrite this integral. So we know that here, this guy is u. Alright, then we notice that, so there's an x there, so we have to rewrite that x. So what I'm going to do is I'm going to start with this substitution equation here. And I'm going to square both sides so that I can get rid of the square root. Right, so we know that it's a u squared is equal to 4x plus 49. Right, then I'm going to subtract 49. So we're going to have a u squared minus 49. 49 is, let's see, 7 squared. So I'm going to go ahead and write it as a 7 squared is equal to 4x. And then we can just divide through by 4 to get u squared minus 7 squared over 4 is equal to x. Right? So let's put everything in. So you have an integral. Right? So dx is same thing as u over 2 du. So I'm going to put u on top. And I'm going to put 2 on the bottom. And du at the end. So that's dx. Right? X is, let's see, we just found that to be, so this is x is u squared minus 7 squared over 4. Right? Then we have square root of 4x plus 49 is u, so you have another u here. Right? So we can cancel u on top and the u on the bottom. Right? So you have 1 on top there. And then 2 and 4 cancel out, so you have 2 on the bottom. Alright, so we can multiply top and bottom by 2 so that the 2 is going to be on top. So I'm going to write it that way. Let's see here. So we have an integral. Alright, so I'm going to multiply, maybe I should write that. So I'm going to multiply top by 2 and the bottom by 2. So that way we can cancel the 2 on the bottom. So there's a 2 on top. Right, so this is going to be equal to 2 is just a constant, so I'm going to just put it outside 2. And then, so that's this guy right here, right? 1 over u squared minus 7 squared with respect to u, right? So luckily, we have this formula already written here, so let's apply that. So we're going to get that. So 2 was already there, right? It's going to be 1 over 2a, 2 times a. A in this case is 7, so it's going to be times 7, right? Then we have a natural log of absolute value of u minus 7 over u plus 7, right, plus some constant c, right? Then we can just clean up a little bit. So you have here, so 2 on top and 2 on the bottom cancel out. So what you get is going to be, let's see, it's going to be a 1 over 7. So 1 over 7. And natural log of absolute value of, right now, u, it used to be square root of 4x plus 49 minus 7 over square root of 4x plus 49 plus 7. And then you have a plus some constant c. All right, so let's type it in. All right, so what we got was 1 over 7 natural log of absolute value of square root of 4x plus 49, and then over, right, let's see, oh, actually, sorry, I forgot to put minus 7 over square root of 4x plus 49 outside plus 7, and absolute value plus some constant c. All right, so let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.